Developing a state-of-the-art AI agent is one thing, but evaluating it, that is where the real money disappears. Testing your agent could actually cost more than building it. We're seeing teams drop $40,000 only to realize their accuracy is stuck at 40%. The old reality of static benchmarks is dead. In the new reality, your run cost is a multiplier of your scaffold and your token budget. We're breaking down the paradigm shift, cost multipliers like browser use, the compression myth, and why testing is the new training. If you want to stop bleeding tokens, you need to understand these numbers. Let's see why in-the-loop cost is the most important metric in 2026.
Let's jump right into this explainer and uncover a massive, invisible roadblock in artificial intelligence that is completely flipping the economics of the entire industry. Seriously, we're talking about something that happens behind closed doors, something the average user literally never sees, but it dictates which AI models survive and which ones fail. I'm talking about evaluation. How do we test if an AI is actually smart, safe, and effective? Well, it turns out figuring that out has become astronomically expensive. $40,000. Yep, you heard that right. That is what it recently costs just to run a single sweep of 9 AI models on something called the Holistic Agent Leaderboard, or HOW. To get this number, researchers had to run over 21,000 individual agent rollouts across 9 different benchmarks. I mean, it is an absolutely staggering amount of money just to essentially give a few AI models a report card. And honestly, it highlights a massive crisis brewing right now in the tech world. So why exactly is evaluating AI suddenly breaking the bank? To understand how we got here, we really have to look at how the basic math of building artificial intelligence has completely inverted. It used to be a very predictable equation, but as our technology has gotten more and more sophisticated, the bill for simply checking the AI's work has skyrocketed. Section 1. The Paradigm Shift, Changing Economics. We are officially leaving the old world of deep learning economics in the rearview mirror. For years, the industry operated on a really simple premise, the old reality. Training an AI model from scratch cost tens of millions of dollars, while testing it was so cheap it was basically a rounding error on the balance sheet. You'd ask the AI a static question, it would give a static answer, and you'd move on. But now, look at the new reality. As models have shifted from being simple text predictors to autonomous agents capable of multi-step reasoning, the tests have become a massive compute bottleneck. We're actually seeing scenarios where evaluating a complex AI model can cost more than training the candidate model itself. The entire ratio has completely flipped. Section 2. Why agents break budgets. Cost multipliers. The sheer messiness of modern AI agents is causing costs to just balloon out of control. When we evaluate an AI today, we aren't just testing the underlying model in a vacuum anymore. The total run cost is a multiplier of the model, the scaffold, which is essentially the framework or the tools the agent uses to interact with its environment, and the token budget. When an AI takes multi-step actions to browse the web or write code, one small inefficient choice multiplies incredibly fast. A simple tweak to an agent's scaffold can multiply your final API bill by 10 times. You are literally paying for every single thought, every single correction, and every single digital footstep that agent takes. And here's the kicker. Spending more doesn't even guarantee better results. On the online mind-to-web benchmark, using the browser-use scaffold with Claude Sonnet 4 cost over $1,500 and achieved a 40% accuracy. But then, the SeeAct scaffold running GPT-5 Medium hit 42% accuracy for just $171. That's an AI configuration costing roughly 9 times more, but actually performing worse. It just proves that a massive compute spend does not always equal competence. In the past, researchers had this great trick. They could mathematically compress static benchmarks by up to 150 times and still figure out which AI was the smartest. It was super efficient. But today's agent benchmarks, they barely compress at all, maybe 3 times at best. Why? Because the unpredictable, winding trajectory of multi-step actions is the really expensive part. And if you have to test by putting training in the loop, zero compression. What you run is what you pay for. Section 3. When testing becomes training, in-the-loop costs. Let's push this to the absolute extreme, where tests don't just use an API, but require actual machine learning from scratch. $9,500. That is the staggering cost for just a single run on a benchmark called PaperBench. In this specific evaluation, an AI agent is asked to replicate 20 actual, peer-reviewed machine learning research papers entirely from scratch. To pull this off, the AI is writing code, spinning up GPUs, and training its own smaller models for hours on end, all to be graded against thousands of criteria. And Paperbench is definitely not alone here. Check out the compute budgets for some of these modern evaluations. The WELL, which evaluates scientific machine learning across physics and biology datasets, requires about 960 hours on a high-end H100 GPU just to test one new architecture. Then there's the MLE Bench, where agents compete in Kaggle data science competitions. That costs around $5,500 per seed. And Research Gym takes about 360 GPU hours per agent. In these advanced scenarios, you can't just ping an API for a few pennies anymore. The test itself requires training brand new models, which sets an incredibly high baseline cost just to step onto the playing field. Section 4. The Reliability Multiplier. The Cost of Consistency. Now, the crucial point we have to understand is that those massive numbers we just talked about only buy you a single, completely unreliable snapshot of performance. I absolutely love this quote from the source material. Running a benchmark once has roughly the rigor of crash testing one car in perfect weather. Modern AI agents are frankly fragile. They hallucinate, they get stuck in endless loops, they fail to use their tools correctly. If an agent solves a complex coding problem once, it might fail the next 7 times you ask it. Performance drops wildly when you start testing for real, actual consistency. Because of that fragility, we have to test an AI multiple times to actually trust the results. And when we do that, the math becomes straight up terrifying. If we run a statistically credible test with 8 reruns for consistency, the reliability requirement acts as an explosive multiplier on the budget. That $40,000 house sweep we mentioned earlier, it balloons to $320,000. That single agent run on Paperbench jumps from $9,500 to $75,000. To reduce the noise and get the actual truth, you have to spend life-changing amounts of money.
Section 5. Pricing out the watchdogs. The accountability crisis. These skyrocketing price tags are triggering a severe accountability barrier. Think about it. When a single rigorous run of a benchmark like JIA costs more than a graduate student's entire annual travel budget, independent watchdogs are completely priced out. Universities, government AI safety institutes, and journalists simply cannot afford to run these frontier tests to independently verify what big tech is claiming. When the watchdogs literally can't afford the leashes, the entire social process of validating these incredibly powerful models becomes dangerously concentrated inside the exact same wealthy labs that are building them. And to make matters worse, right now, the industry relies on cost-blind leaderboards. These are rankings that just show you the raw accuracy of a model without telling you how much money or compute was burned to get that answer. This directly rewards massive waste. Labs can rationally pour millions of tokens and thousands of dollars into a problem just to make their accuracy number tick up a single percentage point on a leaderboard. It completely masks the true inefficiency of their models and deeply distorts our understanding of actual progress. Section 6. Stop paying twice. The open data solution.
Okay, I know this all sounds incredibly bleak, but there is a hopeful, highly actionable solution right in front of us, and we don't even need to invent new, cheaper hardware to do it. The answer lies in projects like Every Eval Ever, which was created by the Eval Coalition. It's basically a standardized metadata schema designed to easily share evaluation logs. Right now, a frontier lab pays for an evaluation sweep. Then an academic group pays for it again to reproduce it, and an auditor pays a third time. We are literally paying retail prices over and over for the exact same overlapping benchmark runs because no one is sharing their detailed instance-level homework. The open data solution is elegantly simple. Step 1, run the evaluation. Step 2, export the full grading trace, meaning all the tool calls and prompts. Step 3, transform it into a shared schema. And Step 4, deposit these artifacts into unified community repositories on open platforms like Hugging Face. By doing this, if a researcher wants to study how an AI failed a specific paper on Paperbench, they can just download the logs instead of spending nearly $10,000 to run the baseline again. Even a tiny, single-digit rate of reuse across the community would put way more money back into the AI ecosystem than any compression technique ever could. Ultimately, evaluation has become the new compute divide in AI. It dictates who gets a seat at the table to govern this technology. We absolutely have to adopt these open data solutions and completely rethink our leaderboards, because all of this leaves us with a critical, foundational question we have to ask ourselves. If only the massive labs building these AI models have the money to actually afford the tests, who do we really trust to grade the future? Think about that for a second. Thanks so much for joining me on this explainer. I hope it gave you a crystal clear look into the true, hidden cost of artificial intelligence.